So I'll be, taking a class on the course that is business statistics. So so there is change in what's called nomenclature of subjects or courses. So now you might already note it. So earlier we used to say MCOM course, BCom course, BBA, etc. Now it's not a course, it is a program. So that's what you must be knowing. And course means paper. So now paper, so business statistics. Earlier it was considered as one of the papers or subjects or something. So subject means common, entire broader perspective. So paper now called course. So MCOM program, we have various courses. Say your first semester you may have 4 or 5 courses. So one of the courses to be studied, that is business statistics. So in this particular business statistics I will be handling 2 hours. So faculty, 3 hours of other faculty engage. So in this particular course, that is business statistics, so one of the chapters to be studied, that is what's called theory of probability. Theory of probability. Probability you might have already come across at your undergraduate level or lower level. So if we have just noted something about this probability, have you come across already this, or have you already studied at least some basic aspects of the theory of probability? Studied, right? So what do you mean by probability then? If you can recall, so what do you mean by probability? If you have studied, so can you recall? So tell me according to what we do. Probability. So for me, when I ask questions, I don't expect to give correct answer that is best. But even if, don't worry, so even if answer is wrong, don't worry. Attempting to answer is more important than giving the right answer. Right. So, prediction. Prediction related, yes. For prediction, you may require probability. When it comes to the meaning of probability, of course, without knowing probability, you may not be able to predict. Okay. For prediction purpose, you may use, say, regression analysis or something like that. There again, because probability is the base for everything. Whether you use, whether you want to predict the future, right, or find out some what's called expected value. In all these cases, so what we say, we make use of this type of probability. So in fact, the entire field of statistics, cannot be understood without knowing what is theory of probability. That is the importance of what's called theory of probability. Therefore, probability. When we come across this type of probability in our day-to-day life, a common person, a layman also, uses this type of probability in his or her day-to-day life. He may not be knowing that, he is using what's called, he or she is using something so sophisticated called theory of probability. But actually, probability is used in our day-to-day life. And therefore, there is nothing what's called complex aspect or a difficult thing as to the term of probability. Because we make use of this type of probability in our day-to-day life. Probably you are right. It is possible that Mr. X may not come for taking class today. Right. The chances that two teams winning a game are equal. Right? So, in all these statements, we make use of these statements in our day-to-day life. Right? Right. Therefore, there is nothing new as far as these types of statements are concerned. So, it is possible that, or it is likely that, the chances. So, possible, probably, chances, correct, likely, all these words indicate or connote one thing. Can you say what is this? All these words. No, we don't say that probably. So it may not. It may not rain today, or there may not be rainfall today. Correct. So that's what we can say. Correct. And now we will have to see, because today when you look into this environment, so they say definitely almost no rainfall. That's what it is. But still we can say probably there may not be rainfall today. But we cannot be 100% sure. The winning entire situation environmental condition may change. Possibility is there, because nowadays everything, including weather, is not very, and therefore one word. So we use these words when likely, possible, probable, chances, all these words are used when. So when we can use. If someone, can you say? So we don't say there will not be any rainfall. Of course, considering the conditions, today we can say like that. Almost no rainfall, so we can use this type of statement that is there. Correct? But still we don't say probably may not rain today. Or the chances that two teams are winning a particular game. Correct? Say two teams, Australia and India. India already won. Right. Second test match also. So once the match is over, then we don't. It is probably because India already won the second test, and then probably India may win. No, don't say that. Correct. Now we don't say. When the test is going on, then we can say probably India may win. Correct. No, every time we don't use probably or likely. And therefore, when you can use this particular word probably, likely, etc. When the action or result is yet to be announced or yet to materialize or something. Right. And therefore, when the result is not yet occurred or not yet result not yet occurred, it means what? And therefore, so we use these words probably, likely, etc. Why? Yes, because result not yet materialized or not yet announced. So when the result is yet to be announced, therefore the situation is what? What is it? More than one possible. So these are all the answers actually. Result not yet announced. These are all the conditions. Otherwise, we cannot have a probability or probability. Result not yet announced. There can be more than one. That is also right. Correct. So now, any other word. When there is uncertain. So this particular word is important. Because all these, result not yet announced, and therefore uncertainty is there. More than one outcome or result is possible, and therefore, because therefore there is uncertainty, and therefore uncertainty. So whenever we have to face uncertainty, and of course, there is almost no situation without uncertainty. Only one thing may be certain in this particular world, that is death. May be very certain. Right. Everything is uncertain. Right. And therefore, almost everything is uncertain. And therefore, whether it is a case of our personal life or it's a case of what's called managerial situation. In all these cases, so we have to face uncertainty, correct? And therefore, whenever there is, and therefore, so situation is very uncertain or not sure, and therefore, let me keep quiet. So as a manager, if a person thinks that everything is uncertain, and why should I think of what's called taking a decision, making a strategic decision? Let me keep quiet, passing the time. That's all. Correct. So if he or she thinks like that, thinking that everything is uncertain, even if a decision is taken, then also uncertainty will be there. Therefore, no need of worrying. Correct. Can you say like that? So whenever we have uncertainty, so as human being at least, right? So we have to deal with this type of uncertainty. Whether as a common person or while dealing with our day-to-day life, or performing or discharging our responsibility as a member of an organization or an employee of an organization. So we have to deal with this type of uncertainty. Now the question arises, how we can deal with this type of uncertainty. Correct. So to deal with this type of uncertainty, so we'll have to make use of what is called the probability. Right. And therefore, everyone, whether as a common person or as a manager, has to face uncertainty. Right. To deal with this type of uncertainty, we make use of this type of theory of probability, or what we say, probability. And therefore, we can say from the point of view of a layman, or in accordance with the layman's terminology, probability indicates that there is something uncertainty surrounding the event or the outcome which is yet to occur or yet to happen. Right. There is something called uncertainty. So from the point of view of a layman or a layman's terminology, as far as this particular term probability is concerned, there is uncertainty surrounding the outcome or the result. With this much we can understand. But from the point of view of a layman, so we cannot say that there is a 100% objective expression for the term probability. A layman's view about the probability may be sometimes biased or subject to what is called subjectivity rather than complete objectivity, or without using, say, some very scientific or systematic method. So from the point of view of a layman, therefore we say there is only uncertainty, and therefore this need not be always based upon very scientific evidence or scientific analysis of a situation. Unlike the case of statistics and mathematics. So unlike a layman's terminology, in statistics and mathematics, what we do, so we present some conditions under which we can make some sensible numerical expressions or statements about this type of uncertainty and apply certain methods of calculating the numerical values of the probability and expectation. That is what we do as far as the theory, the theory of probability, the case of statistics and mathematics is concerned. So here we have to consider some conditions. We present some conditions based upon which we must be able to deal with this type of uncertainty quantitatively. After all, this theory of probability is one of the chapters in the course statistics. And you know what is statistics. So might have studied such aggregates of facts, effectivity, market extent, etc. Professor Horace has actually defined in a very comprehensive manner, although we cannot find a very perfect definition for this particular term, what's called a probability. Right. So, in statistics, we deal with the quantitative information, not qualitative aspects. Even if we have some qualitative aspect, so we will have to convert it into quantitative form. That is very important. So quantitative aspects are considered under statistics, not qualitative. That's what we say. Right. And that is why, so we say all statistical statements are quantitative statements. But you cannot say that all quantitative statements are what's called statistical statements. Right. So all statistical statements are quantitative expressions. But the other way around is not true. The reverse is not true. You cannot say that all the quantitative statements constitute the case of what's called statistics. So like that you cannot say. Right. Right. How? Can you substantiate this one? Can you give an example? All quantitative statements cannot be the case of statistics. At least tell me one example. Give me one example. Pardon? Mathematics. I know why you told like that, mathematics, because mathematics is a separate course. Therefore, it is not statistics. Therefore, mathematics is a quantitative statement, and therefore not a subject. Yes, you can say, because there is nothing. Some logic may be a very good logic, but some so you have to consider some example in such a way that you must be able to be convinced, or you must be in a position to understand clearly what is the difference between quantitative statement and statistical statement. Of course, in mathematics we don't find statistical aspects, only calculation aspects. Here also you have some one or two chapters related to mathematics, indices, binomial theorem, and we apply mathematics while dealing with the theory of probability, particularly while solving some of the problems, and therefore when dealing with the theory of probability, some mathematical aspects, particularly permutations and combinations, idea of permutation combinations are very important. So combination means a group. So that's what we say, a group, or how many combination, group of certain number of things taken, some or all of them at a time. That is combination. Permutation means arrangement. Actually, permutation means arrangement. In mathematics, when we have to find out a group combination, then we use this type of symbol MCR like that, where C means combination. Right. So N means even number of things, N number of things. That is what it is. So R means, what do you say? Because here we don't study in detail what is permutations and combinations. But you require the idea of permutations and combinations. But all, if you want to solve some of the problems related to probability. Right. So therefore, combination NCR. Say N means total number of things. Let us say three people are there. Say A, B, C. 3 people are there. Correct. So you have to form one group, one combination. So you can have different situations. You can take all of them at a time. If you consider all of them at a time, how many groups you can have? A, B, C. 3 people are there. A, B, C. 3 people are there. You take all of them. So you want to form a group. Right. Right. So if you take all of them at a time, how many groups you can? You are right. How many groups? Because for me, our right answer is not, important. But I am not expecting every time what's called the right answer. For me, what is right? Attempting to give, say, answer is the right thing. In the process, if you give the right answer, best. So, lot of question. Right. What is not right? Keeping quiet, or let me keep quiet. Others are there, and if I say something wrong, what if others think bad about me? Because these are all psychological, meaningless psychological aspects. Why should I worry about others? Because if I want to develop, if I want to grow myself, I will have to make an attempt. Correct. Irrespective of what others, good things, that is very important. Correct. And correct. So, and that's why we say, next time should take a business research method. Asking questions is more important than finding the answer. Because usually we are under the impression that, we'll have to give the answer. Even right answer is important. Correct. Otherwise, whenever a test, some questions are given, say mathematics, steps in mathematics for solving some of the problems, say, so we cannot say that exactly you have to follow 10 steps or 5 steps. Some may get the answer based upon 3 steps plus number of steps. Others may get the answer following more number of steps. Right. And then whether we follow more steps or less steps, some logical steps are there, full mark must be awarded. Just because one person followed 3 steps and answer got, another person followed 10 steps, therefore more marks must be given. Not like that. Right. But what is important? The steps, first step, second step, third step, these steps are important. Right. But we may also find many steps are there, 1, 2, 3, 4, but unrelated steps. Answer is there at the end. Mathematics also. Right. Answer is there at the end. Steps are completely unrelated. You may be wondering why the answer is right. Right. Why? Why answer may be right? Steps are wrong steps. Answer is there. Why? Copying. Right. Copying is not right. Right. So answer is there. Then strictly speaking, we cannot give just because answer is there, you have to give more marks or marks. 0 marks may be awarded. We cannot argue. If an answer is not there, 1 or 3 steps are correct steps, we will have to give marks for that. This is the method of valuation. Right. Sometimes exception also, few cases, but always generally, this is what done to deal with this type of subject. Sometimes exception cases may also be there. Answer is more important. While preparing a balance sheet, tallying, what is that? 7,55,000, 7,55,000. That is more important. When you find 7,55,000, 8,58,000, balance sheet is wrong. So usually we try to balance the thing. But in balance sheet, what you have to do? So balance sheet means what? It's one of financial statements. And we see sources and application of sources. That is what balance sheet. At a particular point of time. And that is why when you prepare a balance sheet, you write balance sheet at a particular point of time. Right? Right. At a particular point of time, that is very important. Because the moment the time changes or passes from that particular point of time, the entire balance sheet value may change. Say depreciation. Correct. Correct. So, what is more important? Procedure is important. So, asking questions is more important than, say, finding answer. Correct. Answer is important. I am not saying that. Now the thing is that when you follow the procedures correctly, correct. When you follow the procedures correctly, say while preparing a balance sheet, definitely it must tally. Not always. Sometimes even if you follow the steps very correctly, some difference may arise. Okay. Possibility is there. Correct.
So if you have followed everything correctly, then if some difference is there, then I think what is that? Suspense or something. Correct. Right. So procedure is important. Right. And that is why we say asking questions is more difficult than giving answers. But we have under the impression that asking questions very easy. What do you mean by probability? Very easy. Everybody can ask. Correct. What do you mean by event? Right. What is the value of probability? Anybody can ask. Why should a person or a person like me is required to ask this kind of question? Correct. Everybody, even if he has not studied the theory of probability, can ask. Correct. Right. And therefore, from this, we have to understand what asking questions. And therefore, we should not ask the questions in a what's called light manner, or we should not ask a question in a meaningless or in an insignificant manner. Correct. In a meaningful manner, we will not ask the questions. Correct. And that is why we should be careful while asking the questions. Correct. That is very important. Correct. So that's what I do. So now, so why dealing with the uncertainty, so we make use of what is called the probability. And therefore, whenever there is uncertainty, say, we make use of probability for the purpose of dealing with this type of uncertainty. And therefore, so in mathematics and statistics, so you must be able to deal with this type of uncertainty in a quantitative manner. That is very important. Correct. You have to express uncertainty in numerical form. That is in statistical form. And therefore, all statistical statements are numerical statements, quantitative expressions. But all quantitative expressions cannot be called statistical statements. And you told that mathematics, as a subject, I can say, it is not statistics. Correct. Like that, I can also say not only mathematics, biology is also not statistics. Correct. Right. Right. Other subjects also not statistics. Only statistics is statistics. Correct. Right. And everything else is not statistics. Therefore, so what I require, I want some answers, something more than this. Correct. Your answer is right, so at least you are correct. So so while defining this type of statistics, why statistics? Can you tell me why this statistics is, or one of the uses, or one of the points highlight the significance of statistics? So why statistics is used? Or if you have statistics, what is the use of that? Yes. These are all the basic things. Correct. So you must be knowing. The assumption is what? So basic things you must be knowing. That's what it is. Correct. So mathematical aspects you must be knowing. That's what I want. I was explaining. NCR is a case of mathematics combination. I think I asked this question. So 3 people are there, A, B, C. We take all of them at a time. How many groups? If you take all of them at a time, only one group, not 3 groups. Okay? All of them, one group. Say one group playing. Kabaddi means 7 players are. It's one group. Can you see that 7 players are there? There are 7 groups. Only one group. Because you have taken all of them at a time. Now 3 groups you can have when if you take one of them at a time. If you take all of them at a time, only one group. And what is this group? ABC. ABC. Note that. Whether it is ABC or ACB or BAC, group is same. Can you say that first person A here, B here, C here, one group, and now C first, then A, then B. Appearance changes, just like your coronavirus changes its form, mutation, UK mutation or something. Can you say it changes? No. Whether ABC or BAC, group is same. But now when it comes to the arrangement, so group, so NCR, that's what it is. And therefore, so if you take all of N means total number of things, that's what we say, A, B, C. Three things are there, or three. C means combination, R means how many of them are taken. If you take all of them at a time, then write 3C3. That's what we say. If you take then 3C3 equal to 1, then you find out. So 3C3, so not later, because NCR is always, so formula actually n factorial divided by n minus r factorial multiplied by r factorial. That's what NCR. Find out. So NCR means n factorial, like this. Factorial means factorial, n factorial indicates the product of first n natural numbers. Natural numbers. So first we know now the system of numbers, numbering system. So we have natural numbers or counting numbers. That's what it is. Then we have integers, rational numbers, irrational numbers, real numbers, imaginary numbers, complex numbers. So these are all the aspects related to numbering system. You must be knowing. What are natural numbers? Natural numbers means counting numbers. What are the counting numbers? Can you tell me what are the counting numbers? Tell me. What are the counting numbers? Tell me counting numbers. How you count? So if I ask you to count how many students are here, correct? If I ask you count, so how you count? You count 1, 2, 3, 4, 5. Do you start 0, 1, 2, 3, 4, 5, 6 like that? No. Correct. Minus 4, minus 3, minus 2, minus 1, 1, 2, 3 like that? No. 1, 1.5, 2, 2.75 like that? No. Only counting numbers, natural numbers. Correct. N means natural number. N means natural number. So when 3 people are there, it is meaningless to take 1 and 1.5 of them. We cannot form a group. Correct. So either we can take no person. If we take no person, that is allowed. Although no means 0, it is not a case of counting number. Actually, counting number is 1. But this n must be a natural number. N cannot be 0. Correct. Out of nothing you cannot form any combination. Correct. Correct. N must be of some value or more than 1. So only one person, one thing is there is nothing to be calculated. More than n. So how many of them you take? So factorial, n factorial means it is the product of first n natural numbers. That is what it is. N factorial. So 5 factorial means the product of first 5 natural numbers. That is very good. First, this is the definition for factorial. F-A-C-T-O-R-I-A-L. Factorial notation. Definition. 5 factorial means 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. Or reverse. Usually for our convenience, we write the reverse order. 5, 4, 3, 2, 1. Don't say 0. 4 factorial means 4, 3, 2, 1. Product of first 4 natural numbers. N means 1 multiplied by 2 multiplied by 3 multiplied by 4, 1000, 1 crore, 10 crore, go on increasing up to n. Up to n. If n is 5, 1, 2, 3, 4, 5. If n is 6, 1, 2, 3, 4, 5, 6. If n is n, then 1, 2, 3, 4, 5, 6, 100 crore, whatever may be up to n. What is the previous number? Immediately preceding number, n minus 1. Correct. The last number is 10 factorial. Previous one is what? 10 minus 1. Now you are
No, actually wherever possible you have to apply logic. That is very important. Correct. Because when it is a case of a simple situation, say 10 factorial, 1, 2, 3, 4, 5, 10, what is the preceding number? Immediately we say 10, 9. Because we know, out of practice we say this one. Correct. But when I ask, so what is n factorial, what is immediately preceding number to n, then we find it difficult. Because why? Because we don't think in terms of a rule, a law. That is very important. Particular law is important. Therefore, what is the rule here? N immediately preceding n minus 1. The last one is 10 immediately preceding 1, 10 minus 2. What is the next? Next preceding 10 minus 2. You know 8. Correct. But it is actually 10 minus 2, n minus 2, like that. So in the reverse order, therefore n factorial means what? N minus 1, n minus 2, n minus 3, up to again I don't say n. Now it's in the reverse order. Correct. Up to 1. Correct. Up to 1. Correct. So if we say 1, 2, 3, 4, 5, 6, multiply like that, up to n. Immediately with n minus 1, n minus 2. Now in the reverse order, say what? 10 factorial, 1 multiplied by 10 up to 10. Reverse order, 10, 9, 8, 7, up to 1. Don't say 10 again. Correct. 10 like that, don't say. Correct. Up to 1. That's very important. Correct. So n minus 1, n minus 2, n minus 3 like that. So we say up to 3 to 1. Right. So that's n factorial. At your home you try this one. N factorial. Because NCR means n factorial divided by n minus r factorial. Note that n minus r inside the bracket. R factorial multiplied by r factorial. Correct. So if you take all of them, 3C3, you will get 1. If you don't get 1, then. So if you take one of them at a time, 3C1, then what was the answer? 3. What are these? 1A, Mr. A. Another one, Mr. B. Another one, Mr. C. 3 groups. If we take 2 of them at a time, 2 of them at a time. 26. What are these? 2 of them. X is correct in one sense. Permutation is right, not in combination. Right. So AB or AC or BC. Correct. AB is the same as BA. Whether A stands here and B stands here, or B stands here and then A stands here, order is immaterial in case of combination. That's what it is. Order is not important. But in arrangement, order is important. Therefore, AB is different from BA. ABC is different from CBA or BCA. Arrangement, here order is important. When order is important, it constitutes the case of permutation. Then we write NPR. NPR. P means permutation, means arrangement. Correct. So NPR equal to n factorial divided by n minus r factorial, not multiplied by r factorial. So n factorial divided by n minus r. That's it. Correct. Arrangements. So ABC take all of them at a time. How many groups you can have? Only one group. Correct. Only one group. That is ABC. How many arrangements, permutations you can have? How many arrangements? 6. That is 3p3. Correct. 3p3 means simply it is 3 factorial multiplied by 3 minus 3 factorial. Now note that factorial definition meaning n factorial means product of first and natural number. Correct. There is one exception to this definition. That is 0 factorial is an exception. Right. Actually, as per this definition, we should not consider 0. Right. But definition, correct definition. But exception, 0 factorial, that is an exception. That is, if you get a 0 factorial, it must be considered as 1. 0 factorial is 1. Don't say 0 factorial is, or the class definition is given like this, n factorial, product of first n natural numbers. Therefore, 0 is not there. Therefore, it is equal to 0. Logically may sound very good, correct? Or at least not correct. But it may be meaningless logic, correct? From the point of view of combination, correct? And there was 0 factorial means we will consider 1. Therefore, 3 minus 3, 0 factorial means 1. 3 factorial means what? 3, 2, 1 means 6. 6 arrangements are there. What are these 6 arrangements? Taking all of them. Therefore, what are these? Combination, only one combination, ABC or BAC or CAB. Note that I use or. Probability, that is very important. Use of or, either or, very important. So, and the probability use of these some conjunctions or in grammar, English grammar. Here we don't study in detail what is English grammar, poetry, etc. And that's why sometimes you may find the door is closed by taking class. Correct? Because if some English people come here and hear for English language, they will be afraid of us or something. Therefore, but still some basic English, at least some basic English knowledge is important. And when you use and, so what type of mathematical operation is required? And when we use or, what type of mathematical operation is required? So you must be knowing all these things. Right? And therefore you should be careful when I use or and, either or. Note that combination can be A, B, C, or I don't say and. And means what? It means that we will consider both for combination. If I say or, need not consider either that one or this one. That's what. A, B is for ACB or BAC. Another thing. What are the arrangements? 6 arrangements are there. What are these? 1 or 2 arrangements, quickly tell me. Correct. A, B, C. Then AC. Correct. So, ABC, ACB. BAC, BCA, CAB, CBA. 6 arrangements are there. Like that, if you take 2 of them at a time, 3 people, so you will get some value. Combination, if you take 1 of them at a time, so you will get 1 value. So that is permutation and combination. The knowledge of which is useful while dealing with the problems related to the theory of what's called probability. Right. So, in mathematics and statistics, what I say, we present some conditions under which we can make a sensible numerical statements about this type of what's called uncertainty. Correct. So, numerical expression is very important. All numerical statements cannot be considered constituting the case of statistics. Because one of the while going through this type of definition given Professor Horace Eccles, at the end we find placed in relation to each other. Aggregates of facts placed in relation to each other. What is that definition about that you can find out? Because placed in relation to each other. Why? Placed in relation to each other. Why? Why we place this thing and this thing? Each other. So what some purpose is there? For what? Placed in relation to each other. Why? Placed, these values are placed in relation to each other. Correct. Why? Get this type of value, but some comparison. Placed in relation to each other means what? Comparison. Ultimately, you must be able to compare the things. Then only statistics arises. Correct. Or statistics is there. Otherwise, let us say production of a particular item, say sugarcane, in the year 2019, correct? 120 ton. Only this much. Quantity at the state, 120 ton or 120 kilograms. Correct? Can you say this is statistics? Why? Why this is not the case of statistics? Why? Yes. There is, we cannot do anything. Consider 120, what are you going to do? Correct. Nothing. No judgment can be found. Production of this particular item in the year 2019, 120 2018 100 kilogram order. Now you can say something, correct? Oh, production increased in the year. Many things you can say in the year 2019. Therefore, it can be expected that in future also the conditions remain same, good rainfall, etc. Correct? No natural calamity, etc. More demand, correct? Then perhaps production may increase prediction next year also. Many things you can say. But with only 120, what are you going to do? Nothing can be done. But 120 is a numerical statement, but it is not a case of statistics. In order to have your statistics, you must have at least a pair of values like this, so that comparison is made or is possible. Correct? It's one of the purposes of statistics, that is comparison. Correct? So that is very important. Right? So we say all numerical statements, 120 is a numerical statement, but that's not a statistical statement. But 100 and 120 numerical statements, but also statistical statements. All numerical statements cannot be considered a case of statistical statement, but all the statistical expressions are what's called a numerical statements or quantitative statements or expressions. Right? So we use probability, therefore, for the purpose of dealing with uncertainty in a numerical manner, and that is why we say, unlike a situation where layman, correct, we under statistics and mathematics, or in statistics and mathematics, we present conditions under which we can make a sensible, that's very important, a sensible numerical statements about the uncertainty, and on that basis, so we can apply certain methods of calculating what's called the probability and expectation. Therefore, what we say in mathematics and statistics, the term probability is established by definition and is not related to any form of belief held by a person, say a layman, or is not connected with any form of wishful thinking. Correct? So sometimes from the point of view layman, so sometimes we say some expressions are there. We don't so we don't see the things as they are usually, but we see the things as we think. Correct? And that is why various difference of opinion, conflicts, all these arises. Correct? Because we don't want to see other things as they are. Correct? And we want to see this particular paper as I see this paper, not from the point of view of paper. Correct? So usually, what you have to see the things as they are. Correct? And that is why. But as far as a layman is concerned, possibility is there. While providing the probability statement, he may provide some biased expression for the probability. Correct? Correct. Probably he may come because he or she will be a friend of that person, and that is why expecting, and therefore probably is because kind of belief or subjective aspect arises, particularly from the point of view of a layman. Correct. But in mathematics and statistics, we don't give scope for, and if at all we'll have to depend upon, say, some subjective aspect, then we have a different approach. Actually, later we will study different approaches to the study of the theory of probability. So, one of the approaches, that is subjective approach, that is when it is not at all possible to consider objective things, objective evidence to establish probability, then we will have to depend upon what's called the subjective aspects. That is there. Correct. Separate. And if the objective evidence is there, then we will have to depend upon what's called the objective evidence for the purpose of establishing the probability. But this is not so as far as a layman is concerned. Even if, and it is not the fault of the layman. I am not blaming the layman. Correct. And don't be under the impression that this particular person here, entire class he blamed the layman only. Correct. And thinking that he is a big person or something like that. Don't say that. This is just an example. In the class of only academic discussion. Correct. Not anything else. Correct. So therefore, So what I wanted to say is that there is a possible, even if objective evidence, because layman does not know what is theory of probability. Here we cannot expect a layman that he must have studied the theory of probability. We cannot expect it, and it's natural on his or our part to say probability like this. Say based upon his beliefs or a kind of a form of wishful thinking like that. But in mathematics and what's called so in mathematics and statistics, therefore the term of probability is what? Established by definition, and therefore is not related to or connected with any form of wishful thinking or beliefs as possessed or held by a layman while dealing with the uncertain. And therefore, so we can say in simple words, although we cannot say that we can have a perfect definition for a term of probability, but in general sense we can say, no, probability means it is nothing but an expression of the likelihood of occurrence of an event, or it is the chance of occurrence of an event. That is, in general we can say what is a probability. And this particular probability, it is a number, correct? Whatever we say in words, so we must be able to express in numerical values, and therefore it's not enough if we just say probability, expression of likelihood that an event occur. Immediately we must, numerical thing must come, correct, must be there, or numerical expression must be there, correct. So probability, therefore expression means it is a number which varies between, probability is a number, therefore varies between, probably there may not be rainfall, almost no rainfall. Therefore probability of rainfall today, what is that? Almost no rainfall means probability 0, almost, or at least even if not exactly 0, close to 0. Right? No rain, probability of rainfall today 0. Probability of no rainfall, very careful. Probability of no rainfall, considering no rainfall. Are you sure? No rainfall. Almost sure. Therefore not equal to 0, close to 0. Near 100%, 1. Therefore probability is a number which varies between 0 and 1. 0 for an event which can never occur. Right. 1 for an event which can always occur. Usually probability varies between 0 and 1.